Hello everyone. In this video, I'll be going over 5 questions involving solving triangles using primary trigonometric functions. So here's the first question. We're being asked to solve the triangle, which means we need to solve for all its side length and its angles. So pause the video for a second and try this for yourself. Okay, so for this question, the first easiest thing you can solve for is this angle right here. Because we know that the angles of the triangles add up to 180 degrees, we can simply just do 180 minus 90 minus 36, which gives us 54 degrees for this angle. Now we need to solve for the two other sides. We'll call this one x and we'll call this one y. Because we only know the angles and only one other side length, we have to use trigonometric functions. Now, in respect to the angle 36, we know that 3 is opposite to the angle 36 and x is adjacent to it. Using SOHCAHTOA, we know that in this case we must use the tangent function. So using tangent of 36 degrees, that'll give us 3 over x. And isolating for x gives us 3 divided by tangent 36. And this is approximately 4.13. Now we need to solve for y here. So we have two different ways to solve for y. We can either use the Pythagorean theorem or use trig ratios. So here, just for the sake of it, we'll use trig ratios using the angle 36 and the side length 3. So again, 3 is opposite to 36 and y is the hypotenuse of the triangle, which means that we must use the sine function. So sine 36 is going to equal to opposite over hypotenuse, which is 3 over y. Isolating for y, we get that y is equal to 3 divided by sine of 36 degrees, or y is approximately 5.1. And that would be your full solution for this question. So, for this question, we're being asked to solve for theta. Again, please pause the video for a second and try for yourself. So, for this question, since we're solving for an angle, we must use an inverse trig function. So looking at theta, we look at the two known sides. So 8 is adjacent to theta, and 14 is obviously the hypotenuse of the triangle. Using SOHCAHTOA, this means that we're going to have to use the cosine function. So cosine of theta is equal to adjacent over hypotenuse, or in this case, 8 over 14. Now, we need to isolate for theta, which means that we must apply the inverse cosine function to both sides of the equation. Now these two cancel out, and that gives us theta is equal to the inverse cosine of 8 over 14. Now using a calculator, this gives us theta is approximately equal to 55.2 degrees. And that will be your full solution. So, for this question, we're being asked to solve for x. Now, actually, to solve for x, we must find this side length first, and soon you'll see y. So, to solve for y, you must use trig ratios involving this triangle right here. So, looking at the known sides and angles, angle 20 degrees, 5 is opposite to 20 degrees, and y is adjacent, which means we must use the tangent function here. So tangent of 20 degrees is equal to opposite over adjacent, or 5 over y. Isolating for y, we get that y is equal to 5 divided by tangent 20. Otherwise, y is approximately 13.74. Now, knowing that, we can actually solve for x in a way that we treat this as one whole triangle. So, if this angle is 10 degrees and if this angle is 20 degrees, that means this angle is going to be 30 degrees, which I'll write that right here. So looking at the sides we must solve for is this side. And we know that y here is approximately 13.74. So looking at it from the 30 degrees, we know that this is the opposite side and this is the adjacent side, which means again, we must use the tangent ratio. Getting tangent 30 degrees is equal to opposite over adjacent. Now here in this case, opposite is x plus 5 because we're looking at this entire length. So we get x plus 5 over this length right here, which is simply just y. Now here, as we're solving for x, we must isolate for x. So multiplying both sides by y, these two cancel out and we get y tangent 30 is equal to x plus 5. From here, we just subtract 5 from both sides and we get x is equal to y tangent 30 minus 5. Now earlier, we found out that y is equal to 13.74, which means we can just sub in that number for y in this equation. And computing, using a calculator, we get that x is approximately 2.93. And that would be our final answer. So this is the fourth question, and here we're being asked to solve for x. Now this question is actually similar to the last question in a sense that the side we're solving for is basically the same as this, except now we are given this value and not given this value. Oh, I forgot to add a right angle indicator. There we go. Alright, so the first step here is to actually solve for this little segment right here. So here, we can use trigonometry. 70 is opposite to angle 60 and y is adjacent. The ratio that involves opposite and adjacent side is tangent. So tangent 60 degrees is going to be equal to opposite over adjacent. Isolating for y, we get that y is equal to 70 over tangent 60. And using a calculator, that actually simplifies to 70 root 3 over 3. Now we can use the other angle and treat this whole triangle as one. So first, we know that the two sides that are involved in this is this side right here and this side right here, using angle 30. So this side is opposite and this side is adjacent. Therefore, again, we must use the tangent function. Tangent 30 is equal to opposite, which is 70 over adjacent, which in this case is x plus y, as we're talking about this entire length. So here we must isolate for x. First step in doing so is to just multiply both sides by x plus y. These two cancel out. We get that x plus y times tangent 30 is equal to 70. Now we divide both sides by tangent 30. These two cancel out. X plus y is equal to 70. 70 divided by tangent 30. And just subtract both sides by y, giving us x is equal to 70 over tangent 30 minus y, or simply 70 over tangent 30 minus 70 root 3 over 3, as we established earlier that y is equal to 70 root 3 over 3. So doing this calculation using a calculator, we get that x is approximately 80.83. And that would be your solution. So here is the last question, and here we're being asked to solve for h, which is the altitude of this bigger triangle right here. Now this is a pretty challenging question, but please try it for yourself first. So the key for this question is to actually divide this whole side length into two pieces, like so. So we can call one of them x and call the other y. Whoops. Now we are also given that this whole thing is 20 units long, which means that x plus y in this case will be equal to 20. Now there, if we have x and y, and we know that there's a right angle here, we can simply use trig ratios that both involve h, x, and y. So starting with this triangle, looking at angle 20, h is opposite and x is adjacent, which means we must use the tangent function. So we know that tangent is equal to opposite over adjacent, therefore we get h over x. And now, doing the same thing for this side, again, h is opposite to the angle and y is adjacent, therefore we must use the tangent function. Opposite over adjacent in this case is h over y. Now, for both of these equations, we solve for each x and y. So for the first one, we get x is equal to h over tangent 20 degrees. And for this one, we get that y is equal to h over tangent 15 degrees. So the reason why we do this is because of this thing that we established earlier, that x plus y is equal to 20 degrees. That would mean that h over tangent 20 is not equal, plus h over tangent 15, gotta write that better, is equal to 20. Now here, grab your calculator and simply just solve for the coefficients of h. In this case, you get 2.75h plus plus 3.73h is equal to 20. Now here we can simply just add the coefficients, which then we get approximately 6.48h is equal to 20. And simply dividing both sides by that number, we get that h is approximately 3.09. And that would be your full solution. So that'll be the end of this video, and I hope this video helped you understand how to solve right angle triangles using trigonometric ratios and hopefully made them a little bit more friendlier for you. And I hope to see you on the next video.